Welcome everyone. So I am going to discuss today a topic of SED, which is advanced topic of SED called branching or looping and label concept in SED, how they are used and what are the meaning and the effective usage of these terminologies in SED. So we'll discuss with some examples and I hope you will understand at the end of this session about the concept of label branching and looping. Okay, so I'll start with I got some of the examples already made for you. So we'll start from there. So as you can see in my GVim, I have uh, input which is apple, banana, and cherry in three different lines, as you can see, separated by a new line character. So this is something we'll use as input. And I'll tell you the first command today for inside, which is b, small b. This small b is a branch command to branch unconditionally inside. When I say unconditionally means it is not dependent on a condition like substitute condition. So I'll discuss a little bit more later where which command is then dependent on the substitution, which is a different command. So first example I'll talk here about here is you can see there are three input apple, banana and cherry, and I'm running a set command, but you can see before substitute command is clear. I'm substituting apple with orange, but before that there is a b, which is a unconditional branch. What happens is whenever you are using only this uh, b command, it actually branches uh, every after let's say if the set starts with small b. So what happens is that once the b is encountered, it branches everything to the end of the script, so end of the cycle. So basically it will actually skip the uh, the substitution altogether for all three inputs. So what will happen, I'll explain. So let me just show you this example in Unix so that you can understand. So I'm here, I copy this example and you can see what is happening. So at the app, so to explanation to this example is very simple. So the first input is apple, which goes to the pattern space of SED. If you don't know what are the pattern space, probably you can ask me or probably I'll make another video of that. But the first input goes to the pattern space. So pattern space is the space, temporary space where the cycle of the SED, which is this sequence of commands are executed. So the first input is apple, which goes to the pattern space. Now it hits the command B first, and B is a branch which branches by default to the end of the cycle. So basically it skips this substitution and it ends the cycle itself. So the pattern space has apple, and because there is no minus n used to suppress, so pattern space which is apple goes or flushed out to the output, which is again apple. Similarly for banana and similarly for cherry, you can see. So this is a first example of branching where I'm just using a B command, which is skipping all the rest of the commands and going till the end of the cycle. Okay, this is a first basic example of branching. Now we change it a little bit. For example, I say branch, run this B only for the second line, as you can see now, right? Now this will run only on the second line. So what will happen in this case? Let's examine. So the first input is apple, which goes to the pattern space. Now this is not the first line. Apple is the first line, not the second line, right? So it will not execute this B command because there is a condition to be. So and hence it will go to the next command of the cycle, which substitute apple with orange. So basically substitution has happened now. and apple has now become orange in the pattern space because of no minus n. So apple, so the orange will be flushed out to the output. Now second line comes, which is banana. Banana has, it's a second line, so it encounters two b command. Now b command, so b will skip the rest of the commands, and flush out banana as it is because there is no minus n used. And then cherry, cherry is the third line, but again third line means it will still not run b, but there is no substitution happening, right? Because substitution is apple to orange, so cherry will not be substituted, so cherry will also flushed out. So the output this time would be orange, banana and cherry. So you can see the output is this. I hope this is pretty clear how we can control the branching based on the address or line numbers. Okay, so let's just continue getting more examples for you. Okay, so let's take the third example now, and this time this is the third example, as you can see. So this time let me just copy paste this example and make you understand how this is working. Okay, let me paste it. Okay, so what do you see? This time input is still the same, apple, banana and cherry, but in the set command I am using the substitute command first, substituting apple with orange, and then there is a branching command is used, and then again there is a substitution happening, which is banana to peach. What will happen in this situation? So the first apple will come into the pattern space, and then the cycle starts. Cycle means the execution of command sequentially from left to right starts. First apple will be replaced or substituted by orange, so this is good. So apple has become orange now, and after that there's a b. So b will again skip all rest of the commands on the right hand side till the end of the script. So now orange is left in the pattern space, that will be flushed out to the output. So orange is in the output now. Now banana comes into the pattern space, but there is no substitution happening for banana, as you can see, apple to orange. Now b will again come into the picture, and it will again skip this one. Okay, means banana will still not be replaced by peach because b will skip all the right hand side command. And then cherry comes, and then cherry again, there is no substitution of cherry, so nothing will happen again. So the output would be orange, banana and cherry. Orange, banana and cherry. Okay, so this is just an example how this command is working and how you are using these commands to be in your cases. Okay, let me now show you. Now let me discuss another command, which is t command. T command is same as branching command like b, but this time, as I said, the b command is unconditional, it is not dependent on substitution. But t command, small t, is a branch command, but it is dependent on the condition. It is a conditional command. It depends on the on the command where a successful substitution has been made. Means this command will only be executed once there is a successful substitution has been made just before it, right? So let's check this command and I'll make you understand how this is working. Now you can see in this example, okay, this is our example. In this time I'm not using b, right? I'm using t. Instead of b I'm using t, right? So what will happen in this situation? Let's try to analyze it. So now first apple comes into the pattern space, apple is substituted with orange, right? And this command is successful, right? If this command is successful, then t will be run, because t will run. Why? Because this is successful. If the t is run, then it will skip rest of the command and go till the end of the cycle, right? Because that's the branching. So apple is replaced by orange. Okay, let's check the second command, banana. So now banana comes into the pattern space. There is no substitution happened, right? Because banana is in the pattern space, and substitution is apple to orange. So this time this is not successful substitution. If this is not a successful substitution, this means T will not execute. Hence, it will now allow or pass the command to the third command. It will pass through to it. It will not branch, right? So now banana will be replaced by peach. Okay, so we get peach, and in the third one is cherry, and in cherry there is no substitution anywhere, so cherry will be as it is cherry because there is no minus n, so cherry will be flushed out. So the output would be orange, peach, and cherry. Orange, peach, and cherry. Clear? So this is how you can also play with small t. Okay, I hope this is clear. Now let's move on to the next command. So these are some of the commands I made for you so that you understand the difference between B and T. If this is clear, we move on to the next topic or next set of commands in the same context. So I used example 2 now. So example 2 is also the same, but I have given some different input. So this time my input would be this. Okay, let's just execute it here on the terminal. This will be my input. Okay, what is my input? My input is this: apple pie, apple tart, and banana split. So they are splitted by new line character. So this is my input. Three inputs, right? Three lines. Okay. So now let's go ahead and do some more examples, a little bit more complicated. Not so complicated, but little bit more advanced. So I'll show you this example how this is working. Okay, this one. Okay, so now our input is clear: apple pie, apple tart, banana split, which is coming. And what is happening now that if you look at the set command starts with the pattern matching. So now if any line has a apple, then it will execute this entire block, which is till end, everything, right? As you can see. But in the block, I have a substitute command, also a branch T. Okay, T command, and then there's another substitute. So let's see how it is working. So the first input is apple pie, which goes to the pattern space. It matches with apple, correct? So it goes inside the block because it matches. So now substitution of apple to peach will happen. So now apple pie becomes peach pie, correct? Till this point. And this is a successful substitution, right? This substitution has been successfully done. So that means the T will work and T will then skip the rest of the command and it will go till the end of the cycle. So the first input changes from apple pie to peach pie. Now apple tart will come into the pattern space, second line, and again it matches with the apple, so it goes inside it and apple becomes peach. So this time it will be peach tart, and this is successful substitution, so it will again skip this and exit. And now the third banana split will come. Banana split is not matching with this pattern, so it will skip everything. So banana split will be as it is flushed out to the output. So the output would be peach pie, peach tart, and banana split. So let's check peach pie, peach tart, banana split. So you can see the output is coming like that. Hope this is clear. If not, just go through this explanation one more time, couple more times, then you will understand it better. Okay. So this time I'm showing you another command. This time this command is, as you can see, this time I'm using the command called capital T, which is not small t. So that means run branch, which is opposite of small t. Okay, so the run the branch when substitution fails, right? Just opposite. In small t, it runs when substitution is successful, but in capital T, you do the branching when substitution is failed. Just opposite. So let's try this example and try to understand how this is working. So I'll copy this here on the terminal for you. Let me clean the screen, paste it. Okay, let's try this. Let's try to analyze this command. This time, as you can see, I have just replaced small t with capital T and try to understand what is happening. So the again explanation. So the input apple pie comes to the pattern space, and then we start running our command of SED. It matches with the pattern apple, as you can see. So it goes inside it. It substitute apple with peach. So now apple pie becomes peach pie. And because this is a successful substitution, okay, this is a successful substitution, right? Because apple has been converted to peach. So now apple pie becomes peach pie. So that means this T will not work because capital T works only when the previous substitution is failed. So that means it will also change pie to juice. So the apple pie will become apple juice. Okay, in the first. And the second one, apple tart comes. Again, apple matches, apple become peach, and so it becomes peach tart, and it is successful. So T will not work. So it goes and change pie to juice. But there is no pie juice, so it will not do anything. So basically the first line becomes uh, peach juice, second becomes peach tart, and in third one, because there is no matching, so it will be as it is, banana split. So peach juice, peach tart, and banana split. Peach juice, peach tart, and banana split, you can see. Okay, these are the some very simple examples of branching. Do practice, and if you have questions you can always ask me, uh, and I'll be happy to answer your questions. Okay, so let's just continue and go to another set of examples I have made. So I'll show you the third example now. So this time I will show you or introduce you the concept of labels. So far what we have seen is if we use small t, capital T or B, whenever it hits that branch, it branches till the end of the script, right? It end of the cycle. It skips everything. That is the common concept of branching. But this flow can be changed if I define a label. Means don't branch till the end of the cycle, but branch to the label. Wherever the label is defined, it jumps to that label. It branches till that label, not till the end, right? That's the concept of label. So let's discuss it. So for example, so first of all, how do you define a label in SED? You just add a colon in the front and then you give the label name. So that's how you define a label. So in this, the first example, basically it's doing nothing. Okay. Means in this one, output will still be the pattern space dummy because it is just defining the label, but it is not doing anything else. Okay. So the output pattern space, which is dummy, will be flushed out to the output. So nothing will happen. As you can see, dummy is coming as dummy. Okay, similarly you can have multiple labels. So let's say semicolon, you can define another label, let's say L1, another label by semicolon colon L2. So you have defined three labels here, but they all labels are defined, but yet they are doing nothing. So the output will still be dummy, as you can see. So this is a label definition. How do you define the label? But this is not a practical use, but you should know that you can define more than one label. Now I will show you the example. First of all, I'll show you the example of uh, how this label is working with a uh, with a with a conditional branching T. Okay, so let's just take this example and make you understand it better. Let me copy it here on the shell. Okay, so let's just check here. Okay, so this is our command, and you can see the our input is apple pie, apple tart, and banana split, which is just like previous example maybe. Okay, and what I'm doing this time, you can see. Okay, what we are doing in set command, just see. So there's a pattern matching apple, and inside the block I'm substituting apple with mango, right? And after that, what is happening, you can see. After that, I'm saying there's a T, right? T, which is our conditional branching, right? But this time T is used with along with the name of the label, end. You can see the label at the end, right? Colon end. So this is how I define a label. I define the label at the end. Defining is defining. It is not necessary that sequence of the command should come reach here to in order to define the label. It will automatically detect the label wherever you branch it. For example, if the T is if T capital T needs to run, it is checking. It will look for this label end, and it will jump to that label directly. So basically, it will jump here. This is how it is. Okay, so let's try to analyze this example. First line comes as apple pie in the pattern space. It matches apple. It goes in the block. Apple is changed by mango, replaced by mango. So now this input or pattern space becomes mango pie, and this is successful. If this is successful, T will not execute. If T will not execute, that means it will actually go to the next command. Okay. So the pi will be replaced by crisp. So the output becomes, so the first input becomes mango crisp. Okay, and because this is just the label, it has no significance. It will simply go out. The second line comes and it is apple tart. It again matches with apple, goes inside. Apple tart becomes mango tart, right? Mango tart here, first line, mango tart. And this is again successful command, and the pi becomes crisp, but pi T will not run, right? So it will go to the next line. So pi becomes crisp, but there is no pi in the apple tart. So basically it is still mango tart and end. And the last one again, banana split will remain as it is. So this command is exactly the as previous command, if you see. Means if you don't define the label like this, we are doing exactly the same thing, right? Because in both the cases we are jumping till the end, as you can see. So they will give you the same output. But I'm just showing you one example where how label can be done, and label, and I'll show you more examples later on how label can be also used anywhere else in the SED to make a proper looping concept. So I'll explain you that as well. Okay, so this is the way how we are skipping this substitution depending on the T command. Okay, so let's continue. Okay, so this time in this second example, I'm playing with the label, branching label along with the line number. So let's check this example and try to understand how this is working. Okay. So this is my input apple. So this time the input is changed. Input is apple. First line is apple. Second is cherry. Third is banana. And fourth is apple tart. Four lines I am giving to the input. So what is happening? I am running a sed command. Now what is happening here is that the 2b 2b is means run the branching b. B is our branching command, right? Unconditional. So this run this B on this label branch. Branch is a label name you can see here, but only on the second line. When the line number 2 comes, then only it will come into the picture. Otherwise, it will not used, and you will directly go to the substitution. So the first line comes. It is not the second line, right? So it will not run this 2B. So first line is apple, which is into the pattern space. So apple is replaced by peach. So you get peach, and this is again okay, interesting one, right? So what do you see in this example? I'm just not using only B but also T as well, right? I'm This is the classic example of using B and T both. So let's analyze it again. And you can also notice one more thing, that both B and T are using the same label branch, right? But you can also have a different label for different command as well. This is also possible depending upon what flow you want to control. Okay, so second line, so the first line comes apple, and this is not the second line, right? So it will not run this command, it will substitute apple with peach. So now we have a peach in pattern space, and this is a successful substitution, right? If this is a successful substitution, that means T will run and T will jump to the branch itself. So it will skip cherry with berry. And obviously there is no cherry, so it won't have any effect. So now apple has become peach in the first pattern space, flushed out, and the output is peach. Now we have cherry. Cherry is the second line. You can see If this is the second line, then directly runs the branch and branch to jump to the end. So basically cherry will be cherry only because it skip everything in between, right? So cherry is cherry. So now we have peach and cherry. Third is banana. Again, banana is not the third line, so it will not run this branch. It will go here. But there is banana is not replaced by banana because substitution is failed, right? Because apple is replaced by peach and it is a banana. So that means T will not run. Not run means it will not branch to branch. It will run, it will replace cherry with berry. But again, there is no cherry also. So banana will still be banana. And now again, the last one is apple, and apple will be replaced by peach also, as you can see, as like first example. So we will have peach, cherry, banana, and again cherry. Sorry, the last one is not cherry, cherry tart, right? Because it has a tart as well. Let me show you this example. Same way, let me make banana. Okay, what I'll do, I will write here, uh, let's say banana, cherry. For example, this is my input. So my input is apple, cherry, and third is banana cherry, and fourth is apple tart. So let's see what will happen. So in the first case, apple will be replaced by peach, as I explained. Second will be cherry. Cherry is on the first B branch, so it will skip everything. So cherry will be cherry. Third one is banana cherry. Okay, so the banana cherry will go because it's not the second line, so it will not run this command. It will banana cherry. It is replaced by so now you see command is apple to peach, but apple to peach no substitution happens for banana cherry. But it is a failed case, so T will not run. Means branching will not happen for T, so it will actually replace cherry with berry. So the output of banana cherry will become banana berry. So let's check this time. You can see the output is now banana berry because of this. And then peach tart as the last replacement of here, which is replace apple with peach as I explained previously. So these are some classic examples of branching using the labels. Okay. If you don't understand, go ahead and watch the video multiple times. You will get to know all this concept very much clear. Okay, let's go ahead and go to my next example case. Okay, so I made more examples now. Now we will use the concept of looping. So as you know, in SED, we do not have concept of loops like while, for. So if that is not the case, can we still make loops in SED? Answer is yes, you can have a looping in concept in SED also, but you have to use branching and labels in order to emulate this behavior of looping. So how it is possible? Okay, let's check the example and then I'll make you understand. So let's take the first example, this example, and hopefully you all will understand what I am talking about. Okay, so let's run the first example. This is my first example. So it's a simple example, but try to understand how it is working. So echo, there is an input, the one input to the set called apple. Apple goes to the pattern space. Now command starts from left to right. Okay, here label is defined first. Label can be used anywhere, but it has no role. Role will come only when the branching comes, okay, and then it jumps to that label, right? In the previous examples, I used branching first and then the label at the end. So it was jumping from left to right, but this time it will jump from here to here. But there is a problem here, so I'll explain you what is the problem. So input is apple, right? So the label is loop start. It is nothing but a pointer where the branching will jump. Now apple is replaced by peach. This is also good. You can see apple will be replaced by, there is no skipping, right? Skipping will go from here to here this time, right? As you can see. So the apple is now replaced by peach. So now the pattern space has a peach, correct? Now it it encounters the branching, and branching is saying, okay, jump back to the label called loop starts. It will jump back here again, and now substitution again happen, but this time what is there in the pattern space? In the pattern space now there is a peach. So the peach, there is no substitution because peach is not replaced by peach, right? It's apple to peach. So it will, no substitution will happen, but B is not, B is unconditional. Okay, it will keep on looping and looping and looping. So basically it will become an infinite loop. Okay, you can see it is infinite loop. Why it is infinite loop? Because after the first substitution it goes into the infinite loop. How do we know after first substitution it has happened? I have a way to show you. You can use a p command also, which is a print command, right? What will happen this time? When substitution happens, it will print that substitution. So you will see that it will print for the first time. You can see first time apple is replaced by peach, and then print happens, but the second time there is no substitution happening, right? Because the pattern space is now peach. So there is no peach which is replacing, but looping is continuously happening. So it is an infinite loop. So you have to stop it here by Control C. I hope you understand. Now what we'll do, we'll replace this B with conditional branching, right? Small t. So what will happen in this case, guys? So what will happen? So let's see. So input is apple. This is a label. Apple is replaced by peach. So we have a peach in the pattern space, and this is a successful substitution. Yes. So if this is successful, loop, this T branching will go to the first loop. So basically, no, I mean the T branch will go to the label loop start. So it will loop here, and now pattern space has peach, and apple to peach substitution will not happen, right? Because because it is apple to peach, and we have peach already in place in the pattern space. So this will be unsuccessful. If it is unsuccessful, so no branching will happen, right? So means it will not loop back to here, but it will simply terminate till the end. Okay. So basically only one time apple to peach substitution will happen. So let's check. Okay. Why it is coming two times peach? Because SED is not using minus n, right? So what will happen if it is not minus n? So first time it is, the peach is printed by the p, right? And once the command is completely terminated, the pattern space has only peach, right? That peach will be flushed out to the output. Hence, there are two peaches. So you can also control this output by using minus n. If you use minus n, then the last peach will not be flushed out to the output. You can see only one time peach is coming. So this is quite easy. If you don't know what is minus n, again, go through the SED manual and check what is minus n, and you will know it very fast. Okay. Now I'll show you the last example. This time I will use capital T, this example. So we have a, okay, so the input, this is very interesting one. So input has one line only this time, apple, apple, banana, apple, and I'm using the SED label is loop start, substitution is happening apple to orange, and then there is a capital T, and then there is a loop, there is a branching, right, for to the label loop start, and then there is another substitution called apple to peach. So what will happen? There is one line, the input go, the pattern space get this entire line, apple, apple, banana, apple. Now, now we start our command. This is just the label, so it goes next line. And banana is replaced by orange. So this banana will be replaced by orange. So the pattern space has got apple, apple, orange, apple, right? So we have apple, apple, orange, apple. Now this is a successful substitution. So the T will work on it, right? And it will loop back to label. So it goes here. So it will not run this at all, right? It skips it. So it comes here. Now again, the pattern space still have apple, apple, orange, apple. So this time apple, apple, orange, apple means this time substitution will not happen, right? Because there is no more banana. So this T will fail. And if the T will fail, it goes to the next command where apple will be replaced by peach. Which apple will be replaced by peach in this case? First. Why? Because there is no G. First occurrence will be replaced by peach. So the final output would be peach, apple, orange, apple. So I hope this command, this one is very interesting example. Basically, if you learn it, you will know the concept very clearly. I hope the looping concept makes much more clarity now in these situation. Okay, so we are pretty much done. Let me show you the last example of this. I have made a very good example for you all to understand how this is working. So this time we will use the same concept of branching and label, but this time I am introducing a command called capital N. So just if you do not know what is capital N command in SED, let me just give you the introduction of it. So basically the capital N command of SED actually appends the next input to the pattern space. So if you don't understand, I'll explain you. So for example, if you have three lines A, B, let me make maybe four, A, B, C, and D. There are four lines, right? So let's check. So you can see there are four input. What will happen if I'm using capital N command, okay, like this in SED? What will happen? So you know, right, the default method. So we start with SED starts with reading A to the pattern space. Now A is in the pattern space, and now the command starts, right? What capital N will do, it will also append B to the A. So the pattern space gets A and B separated by the new line because it appends, okay? So the pattern space will get A new line B. That is what N will do, capital N. So it will append the next line also in the pattern space. That's what it does, okay? So I'll show you how. So you can you can run a P command here, for example, and check, okay? So let's use minus N for now. So you can see what will happen. So the first time the input is A back because of capital N, the pattern space gets A and new line B, like this part. So this part is now flushed out to the output, okay? And the cycle is completed. Now C will be read to the pattern space, and now N will run on that. So it will also get D, and then C and D will be printed by P command. It doesn't look like that it is doing that way, but I can prove you. What you can do is you can say, for example, you can also use equal sign in between. So this equals actually prints the line number for your pattern space. But please remember, if there are two lines in pattern space like A space A new line B, it will always equals will always print the line number of the last line. So this time I will see the output as 2AB and 4CD. 2AB and 4CD. Why? So the 2 why? Let me explain you. So input is first A comes to the pattern space, right? And then capital N is run. So we get A new line B here. And now equals will run on that A new line B. And equals will run on the last line of the pattern space. So B, what is the line number of B is 2. So that is always printed. The line number is always printed on the top. So 2 is printed, and now P command will print whatever is left in the pattern space. What is left in the pattern space? A new line B. So you get 2AB. Similarly, you will get 4CD. Okay, this is how you work. It works, capital N. If you are confused, you can ask me. Okay, I'll explain again. Okay, so going back to one of the examples. So how capital N can be worked out. So for example, look at this example. This is my input, and this input is hello, and then second one is HEL, and third line is LO, and fourth line is hello. I want to combine HEL and LO to make it hello. Okay, so how can we do? We can do it by capital N command. By capital N command. How this will work? So I'll show you. What you have to do is if the if the first line comes, it needs to be flushed out directly as it is, right? Because we want to work on only on this second and third line. So I will say if this line number is 2, right? If the line number is 2, then run a N command, because I want to if the line number is 2, which is HEL, then run the N command, and N command will get HEL and LO in the pattern space like append, right? So this is clear. Now what we have to do is we have to substitute new line, because what we have to do basically, we have to combine HEL and LO. So substitute new line with null. So this new line null will merge HEL and LO, right? So substitute new line with null. This is it, and that's it. I hope this will work. So let's check this example, and you can see first hello is, because it is not the second line, then it will be flushed out to the output. Then it comes to second HEL, then it goes inside this entire block and execute HEL and LO and make it one line. And the third line is again hello, which is not, again address is not satisfied, so it will not run anything. It will flushed out hello as it is. So this second hello is being constructed by this command. Okay, this is a simple example but very effective. So you can learn this example. Now we have a problem. I'll show you a problem and we have to resolve that problem. So the problem case is this, that we have we have, sorry about my throat. So we have we have this input, and I want to get the output like this: A space B space C space D, using SED, right? With the TR it's very simple. You just translate a new line to the space. I think that will work. So let's check with TR first. TR, translate new line to space, right? Input should be this, right? Echo pipe TR. You can see it is working. There is a problem that the last new line is also converted to the space, right? This one, but that can be managed by some more commands, which is fine. So question is, how can we do it in SED? So very first thing you can say, oh, we can simply use substitute command. Will it not work? So let's try that. Okay, so and I'll explain you why it will not work, right? So this is what we are doing. Substitute globally, new line to the space. Sorry, there should be a space, right? In between here, and run it again. Nothing will happen, and I'll explain you why. Why it will not, why nothing will happen? Because in the pattern space you get only A, right? And if you execute the substitute new line with space on A, obviously nothing will happen. And then A will be flushed out as it is. Now B will be put to the pattern space. Same thing happen with B. That's why with this situation, it will not work. With normal set substitution will not work in this situation. Okay. So what is the solution then? We can have something to try. So what we can do is we can say, let's try with N. So N will fetch A and B together in a new line, right? first time. And if this is the situation, then we substitute uh, new line with a space. Okay, global is okay. You can have or may not have global because there is only one new line space, one new line case. Right? So let's try to run this command and see what will happen. Okay, so something has happened, but not what we wanted, right? We wanted A space B space C space D. So what is happening? First A and B comes to the pattern space. A comes to the pattern space. N will run. So N will make A new line B into the pattern space, and this new line is now replaced by a space. So you get A space B, and the cycle is over. And now the SED will read the next input, which is C. So this is not the solution. Again, this will have a problem, right? So how can we fix this problem? This problem can be only fixed by looping and branching, because what we need to do is we need to keep on running n until the last line. So basically, ultimately pattern space gets uh, these elements A, B, C, D in the new line, then we can run the substitute with a G. So how can we do it, right? So let's check it. So what we have to do, we run the set command, and here I will define a label first. I will say label is small l, for example. This is my label, right? Label. And here I will say if the line is not the last line, what is the condition for that? You can write uh, dollar not. Dollar not means run this command what I am writing now. So I am writing a command called B, which is branching, and a label L, right? BL. So only run the BL. What will happen? So basically what I'm trying to explain here is that I want to I want to execute BL if this is not the last line, right? If it is the last line, then BL will be executed. So not last line not. If this is not the last line, execute a BL on it, right? This is what I'm trying to execute. And then I am running a N here like this. So what will happen? Maybe this will, no, there is something more I have to do, okay? So what you have to do is add a N in between. What will happen in this case? Just let's check. So there's a label L is defined. Now run a N on A, right? So we get A space A new line B, correct? And now because this B is not the last line, right? Is not the last line. Then if this is not the last line, run the B again. If this is not the last line, run B again. So it will jump back to label L and again run N on this existing AB. So existing AB will get C now. So now we get in the pattern space ABC, and then it comes to the last. So uh, now again we have ABC. So it goes here N again. Now we have ABCD all into the pattern space, and this is the last line, right? If this is the last line, then don't run B. If don't run B means go ahead. So we move ahead and say here, okay, substitute new line with a space globally, okay, globally, because we have four new lines now. This should be the command which will work. So you can see the output now. So one more time I will explain. I have defined a label L, and this label is just for the jumping of BL, right? This one. When this jumping BL will occur, it will only occur It will occur whenever it is not the last line. And it is the last line, then don't run. If it is the last line, dollar is the last line, okay? If it is the last line, don't run BL. That's all I'm doing. So what will happen? So first A comes to the pattern space. Now N will run. N will get A new line B. So we have A new line B. And because this is not the last line, if this is not the last line, then run B again. So B will loop back to means BL, run BL, loop back to L and again run N. So we get A, B and C in the pattern space. Now again, this is not the last line C, loop back again. So we run N again and we get A, B, C, D. And now A, B, C, D, the D is the last line, right? If D is the last line, then don't run B. Move ahead and simply run the substitution on all four A, B, C, D and substitute the new line to the space globally with G and you get the output. So this is a classic example of how can you deal with such situation using N and your branching and looping concept. This is all I wanted to discuss today, guys. I hope you found this SED branching, looping, labeling concept of SED useful. Thanks. Keep watching, keep learning. Bye.